Alright, you guys all ready to go? Or you need a second? Okay. Alright, here's the first thing. We're going to talk about two ideas today. One of them is called the inverse, and one of them is called the determinant. And then we're going to connect them both together, and then it'll help us solve that triangle area problem that we just did. But before we begin, I want to give the room a task. I want everybody on the right side of the room, well, first I want everyone to plug these both into your calculator. Yeah, I'll let you know. Okay. So right now, take your calculators out and plug both of those into your calculator, A and B into your calculator. All right?
Oh, shoot.
Whoa, 22.
Yeah, that's what I did.
Okay. So take a moment and plug those into your calculator screen. If you are on that side of the room, if you're on the left-hand side of the room, that's you guys over there, okay, everyone in there, I want you guys to multiply A times B in your calculator. If you're on the right side of the room, that's everybody on this side, over on this side of the room, I want you guys to multiply B times A. Now, yesterday, on Tuesday, we already figured out that you do not automatically get commutativity in matrices, okay? So I want you guys to sort of look at something here interesting. So right side of the room, you guys do AB. Left side of the room, you guys do B times A, and then we will reconvene. All right. Hopefully, you guys, so everyone on the right-hand side of the room, A times B, what'd you guys come up with? You got 1, 0, 0, 1. And then B times A, what'd you guys come up with?
1, 0, 0.
Ah, 1, 0, 0, 1. Okay. Well, this is interesting because we just realized the other day that, commutativity is not always the case. But do you remember back in the day, like when you learned something called the, if you multiply a number by something and it gives you back 1? No, not the reciprocal. The identity, right? This is the multiplicative identity. The number you multiply to get back this 1. Well, it turns out matrices have the same thing. So this matrix right here and this matrix right here is called the multiplicative identity matrix. Identity matrix. And we call it capital I. Right? So this thing is called, when it has this form, this 1, 0, 0, 1, it's called the multiplicative identity matrix. So in a 2 by 2, the identity matrix will look like just what we had there, 1, 0, 0, 1. In a 3 by 3, the multiplicative identity matrix will look like this, 1, 0, 0, 0, 1, 0, 0, 0, 1. In a 4 by 4 square matrix, the multiplicative identity will look like this, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Does anybody notice a pattern here or anything special about these? Yes. Okay, exactly. Along the main diagonals, you will have 1s. That's called the main diagonal of a square matrix. The matrix has to be square, right? This is called the main diagonal. So I guess that's worth writing down. So that's called the main diagonal. Okay, so if your main diagonal consists only of 1s and you have zeros everywhere else, this is defined as the identity matrix. Okay? For that. So can this extend, like what would an n by n matrix look like? Square matrix, identity matrix, what would it look like? Exactly. There would just be 1s along the main diagonal. So this can extend anywhere out to, if for any n by n matrix, you'll have 1, 0, 0, blah, 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 0, 1, 0, blah, 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 0, 0, 1, blah, 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 and all the way down, right? So zeros along the main diagonal. So it can be expanded to any n by n square matrix. Okay? So I just rewrote again what we were given to. So here's what we can say. So because A times B was the same thing as B times A, which was the same thing as I, and I, remember, is the definition of the identity matrix. Because this statement is true, we can say the following, that B is the inverse is the multiplicative inverse, I should say multiplicative, so the multiplicative inverse of matrix A. And sometimes we call the multiplicative inverse A inverse. So it would look like that, okay? A inverse. So this should already be in your calculator, so I'll show you. Bring this down over, can I bring this down over here? Yeah, there we go, okay. So your calculator is also really good at figuring out inverses, okay? So in our matrix, if we go to the matrix column, and I want to edit this one, and I want to make it a 2 by 2, and I want to enter in matrix A, so 1, enter, 2, enter, 3, enter, then 4, enter, alright? So I got that 1, 2, 3, 4. I can go second quit, and then I can go underneath the matrix button and push matrix 1, and then I can actually just calculate the inverse by actually hitting that inverse button right on my calculator screen, push enter, and I should get exactly matrix B, -2, 1, 1.5, -0.5. So this verifies here that matrix B is the inverse of matrix A. Notice that we just can write it as A inverse. So I wanted to show that to you and share that with you as well. Alright? Here we go. There's a special note that comes with this, and the note I'm going to write for you in orange, okay? Special note here. Okay? Not all square matrices have multiplicative inverses. Not all of them have multiplicative inverses, okay? It's not a guarantee that they all will. If they do not, the special name that we use for it is singular. So if we determine that a matrix does not have an inverse, the word that we use to describe that matrix, it's a vocab word, is just the word singular. Okay, so there's two examples here. There's example A and example B. I want you guys to practice using the calculator. You're trying to answer the question whether or not B is the inverse of matrix A. Practice using the calculator right now and determine whether or not B is the inverse of A. So, part A, example A, what'd you find out? Is B the inverse of A? That's the question that we're trying to answer. Is B the inverse of A? Okay, you say yes. Why? Yes, B is the inverse of A. What did you do to determine that? So you plugged in A, and then you found the inverse and got B. Did anyone do anything differently? No? Everyone did the same thing? Flo, what'd you do? So you did the same thing. So you did not do anything differently. Yes, Brian. You multiplied them together. What'd you get? You got the identity matrix for a 3 right there. So if you multiply A times B, that would give you the identity matrix, all right? How about for part B? Yes or no? No, these are not inverse. No, B is not the inverse of A in this case, right? If you multiply them together, or A times B, you would not get the identity matrix 1, 0. Okay, so far, we can find the identities, or we can find whether or not a matrix is an inverse of another one. So every square matrix, so the matrix has to be square, with real number elements, so that means we don't have any complex numbers in there, but just have to be real numbers. It has a number that's associated with that particular matrix. We call that number the determinant. Now, a loose interpretation of this is kind of like we all, as Americans, have a social security number, right? So there's a number that's associated with each person, right? The only difference between this one and the determinants is that my social security number is guaranteed to be different than your social security number, right? So it may not be the case, though, for determinants. It could be true that one number is assigned to two different matrices, so it's not always true. But the idea that a number is assigned to something is similar to a social security number being assigned to a person. So there is a number that we can assign to every single square matrix, and that number has a name. We call it the determinant. So that's the definition of what it is. Does that help you out understand the definition? Okay, sometimes that number will be positive. Sometimes that number will be negative. Sometimes that number will be 0. So a determinant can be positive, negative, or 0. and it's not necessarily unique. Okay with that part? You guys good so far? Okay, awesome. Okay, let's talk about how we find this number called the determinant. For a 2 by 2, it's really straightforward and really easy. So I'm going to define matrix A as this 2 by 2. I'll go Q, R, S, and then T. So matrix A is a 2 by 2 square matrix. The elements are real numbers, and those elements are Q, R, S, and T. Well, then the determinant of A, which we denote as this, the determinant of A. That's how we write the determinant, det of A. The determinant of A can be found by taking the product of Q and T and subtracting the product of S and R. So Q times T and subtracting the product of S and R. Just like that. Pretty straightforward.
It's a cross, right?
Yeah, it's a cross. So multiply Q times T and then get that answer. Multiply S and R, get that answer. Subtract the two. That's how we get the determinant of a 2 by 2.
Wait, this
Okay, so regardless of what those elements are, I have a 3 by 3 square matrix. In order to find the determinant of a 3 by 3 matrix, this is what you have to do. The first step is you need to copy column 1 and make a new column, column 4. A, D, and R. This is what you have to do. Okay? You also need to do the same thing with column 2. Take column 2 and make it column 5. So B, E, and S. Right? Okay? All I did was I copied it and moved it over, basically.
Is that like a new one? You promise?
Yeah, it's only there for the purpose of helping you visualize what's going on for the determinant, okay? So then I like to do my setup like this. The determinant of A, well, just like it was for the 2 by 2, it's some stuff, and then it's minus some other stuff, right? So it's going to be the same thing for a 3 by 3, but the stuff is just going to be different stuff. So it's something minus something else. Okay, so I have some setup here, all right? Here is what you do first. You need to get the product starting with A and going along the diagonal all the way down. That would be A times E times T. So that's A times E times T. It doesn't matter what they are. You have to multiply those together. Then you move over to the next column. I don't want to use green, I'll use red here. And you get B, F, and R. This is why you had to move. This is why you had to move those columns over. Otherwise, you'd run out of room there. Okay? So this, you're going to add this to the product of B, F, and R. And we have one more to do, and I'll do it in blue for you. Yep. The structure of it is really weird, but all you're doing is multiplying and adding, right? So, and then C, D, S. So this, I'm going to add this to C, D, and S. Okay? For the subtracting, we go with the opposite direction. We start down at R, and we go up this way. R, E, C. So that's in my bold purple. So minus R, E, C. All right? I'll use a different color now we'll go brown. And then I have S, what is that? SFA, right? Plus S times F times A. And then finally, my last one, I'll have to do in this color, it looks like TBD. T, B, and then D.
TDB.
It doesn't matter because 4 times 3 is the same thing as 3 times 4. Let's do this example together. I have A is 3, -1, 2, and 5. I am interested in figuring out the determinant of matrix A. All right, well, then I know that it's going to be this times that, which is the number 15, right? And then I'm going to subtract off from that this times that, which is the number -2. So the determinant of A is equal to 15 minus negative 2. So how much is that worth? That's worth 17. So 17 is the number we can assign to matrix A. 17 is the determinant, and it happens to be a positive determinant. Okay, your calculator, of course, has the ability to do this. I want you to know how to do it on the calculator, but it's not enough just to rely on that calculator the whole time. So here we go. Let's plug this in together. So second matrix, edit. Here we go. So I'm going to go a 2 by 2, 2, enter, 2, enter. So let's go 3, enter, negative 1, enter, 2, enter, and 5, enter. And once I've got that, I can quit. And now that matrix is stored into my calculator. And I am interested in the determinant. So if I go second matrix, and I go to my math folder, the very first one is DET, which stands for the determinant. So if I push enter, the determinant of, now the calculator says the determinant of what? And you enter in the first matrix that we have stored in there. I push enter, and look, the calculator has produced the same exact result that we have calculated, and now we know how to do it. Okay, here's a 3 by 3, and I won't ask you to do anything larger than a 3 by 3 by hand. Okay, so you have to know 2 by 2s and 3 by 3s. So here's the first step. Our first step is to recreate our column number 1. So I'm going to have 1, 0, and 3. And recreate column number 2, 0, 4, and 5. Lots of zeros in there. And we like zeros because anytime there's a 0, it's going to cancel out that whole entire number for us. And we're going to be good to go. So set yourself up for success. The determinant of A is going to be some number. I'll use black here to keep everything consistent. So it's going to be some number, right? Minus some other number over here. Okay, so the first number we're going to find by taking this route. Okay, 1 times 4 times 2. How much is that?
8.
That is the number 8. Okay, awesome. Okay, good. So I'm going to add that to something over here, and then add it to something over here, and then get this number here, and then this number here, and then finally this number here. Okay, so if I fill all those in and then do what I'm supposed to do, I'll be good to go. Okay, some of you already figured it out, and that's awesome. Check this out. 0 times negative 1 times negative 3, well, that's just 0, isn't it? Because if there's a 0 in there, then I'm good to go. And check this one out. Hey, negative 2, 0 times 5, well, hey, that's also 0. So I don't have to worry about that one. Okay, let's go backwards the other way, so I'll go orange. So 3, 4, and negative 2, how much is that worth? Negative 24 would go in that box right there. Okay, let's go this color blue. So I get 5, negative 1, and 1. How much is that worth? That's worth a negative 5. And then I am noticing that in my black at the very end, I would have 2, 0, and a 0. Whew, that goes away. That gives me a 0. So it looks like this is the number 8 minus this is the number negative 29. So I'm thinking that that's the number 37. So 37 is the number that we can associate to matrix number A. 37 is the determinant. Please go ahead and check it on your calculator right now. Okay, so we've talked about inverses so far in this lesson. We've talked about determinants so far in this lesson. I haven't related the two yet. This is the relationship between the two. Okay? You can find the inverse of a square 2 by 2 matrix by doing the following. So given A is this 2 by 2 matrix, then A inverse, sorry, I don't really know how that there. A inverse can be found by 1 over the determinant of matrix A itself times this matrix here. D, negative B, negative C, A. So this right here is the key concept. I know, right? This is such a trip. This is a trip. Now, here's the reason why. I want to point out a few things to you, okay? I told you earlier that not every single matrix has an inverse. And can you see a reason why a matrix would not have an inverse? Yeah. Because why? You guys just figured it out. Go ahead and say it. Yes, if the determinant is 0, you're noticing that this is a scalar, right? So if your determinant is 0, we're going to have 1 divided by 0, so it would be a singular matrix. So a conceptual question I might ask of you would be, create your own singular matrix. Right? Think about that for just a second. Create your own singular matrix. You can keep going with this.
You just have to have zeros in every column.
Yeah. So you can write this. Well, other than that matrix right there. This is 1 over, remember, this is A times B minus C, sorry, A times D. A times D minus C times B, right? The determinant of A is just that thing right there, times this value here, D. Okay?
So you just have to have a 0 in either A or C.
That's the same thing right there. Yeah. Okay?
Or you can make
So,
them equal each other. So that
yeah. Okay? So here we go. So the determinant of A can be written. Some people don't make the connection that, the determinant of A is this thing. It's AD minus the CB value over there. Okay? So that's how we find the inverse by hand of a 2 by 2 matrix. Okay? Okay? All right. In the cloud, let's pretend that we don't know that that's the inverse. Okay? And we're going to try and get the inverse of matrix A. So here's what we know. The inverse matrix is 1 over... Okay, 1 times 4 minus 3 times 2 multiplied by, switch the 1 and the 4, change the signs of these, right? -2, -3. I'm applying exactly what the formula says to do, okay? All right, let's keep going with this. Well, that would give me, this is 1 over, what's 4 minus, this is -2, right? This is -1/2, right? Times all of this, 4, -2, -3, and 1. Well, look what that gives me. What's -half of 4? -2, 1, 3/2, and -1/2. Hey, oh my gosh, that's exactly what it says right there. And that's how it's done. All right, so far we now know what a determinant is. We now know how to find a determinant. Now what can we do with a determinant, right? Well, at this level for us, one nice thing that a determinant is used for is calculating the area of triangles. The area of a triangle. So let's say that I'm given a triangle with these 3 points. We'll just call it x1 and y1. We'll call it x2 and y2. And we'll call it x3 and y3. So these are my 3 points that I've been given. The area of a triangle with these 3 points, so the area, is going to be 1/2 the absolute value of the determinant of the matrix with these 3 points, x1, y1, and then the number 1, x2, y2, and the number 1, x3, y3, and the number 1. So this is really convenient when the 3 points given to you are not in the easiest location to be found. So I want you to go back to the back side of that sheet that I gave you, because at the very beginning of class I gave you a triangle with these 3 points. I gave you the points -2, 1, yeah, absolute value. And then I also gave you 3 and 4, and then I also gave you 4 and -1. And we have a couple of guesses on this up on the whiteboard. I have like 4 different ones. Well, right now we're actually going to figure it out. So we're going to create a matrix, and we're going to figure out that the area of the triangle with these 3 given points is 1/2 the absolute value of the determinant of this matrix right here. -2, 1, 1, 3, 4, 1, 4, -1, 1. So what are we going to do? We're going to enter this 3 by 3 into the calculator. We're going to find its determinant, and we're going to cut it in half, and that's going to give us the area. Okay, so plug in my 3 by 3, so I'm going to do -2, enter, 1, enter, 1, enter, 3, enter, 4, enter, 1, enter, 4, enter, -1, enter, and then 1, enter. All right, there we go. So second quit, right? And then second matrix, I want to do the determinant of this, so I'm going to do the determinant, so push enter, of second matrix number 1. And I'm going to get this answer of negative 28. Is that the area? No, what do I do to it?
1/2.
I take the absolute value, which would be 28, and then cut it in half. So I'm looking at an area of 14. So given a triangle with these 3 points, the area is going to be exactly 14 units squared.